morning student, let us start our science class. Yes, already we have started a new chapter, that is materials, in that metals and non-metals. Yeah, in previous class we have discussed about the physical properties of metals and non-metals. What are the physical properties? Yes, they are, metals means they are shiny, hard it is, upon that malleable, ductile, many things, ringing sound it is giving, conductor of heat and electricity, all those things we studied. What about the non-metals? They are completely opposite of that one. They are dull looking, not very hard, upon that they are not giving any sonorous sounds, ringing sound is not giving, they are not a good conductor for heat and electricity, all those things we have studied. Upon that we come to know that what is the different uses of metals in our daily life and non-metals in our daily life. Where we are using metals? Yes, we know that all machinery parts, rockets, trains, all those things. Upon that, what about the non-metals? Non-metals we know that we are using as a fertilizer, upon that in crackers, disinfectants, upon that antiseptic solutions, many things we know. Upon that water purification like bleaching powder, chlorination, etc. Yes, so we come to know that we have number of uses of metals as well as non-metals. Next, we just started the chemical properties of metals and non-metals. In last class, by doing one activity, we come to know that metal like sodium is very reactive element or is reactive metal. It is, even though it is very soft, it is very reactive with the water. So we come to know that how fast it is going to react with water. Vigorous reaction we come to know. Yes, upon that we study the chemical equation of the formation of sodium hydroxide. Yes, after that, while comparing the non-metals, how it is non-metals? They are not reacting with water. Phosphorus is very reactive with oxygen we come to know. Yes, so that is reaction with water. In last class we completed reaction with water. Both metals and non-metals, how they are reacting with water. In today's class we will study more chemical properties, okay, properties of both metals and non-metals. Now, second chemical property is reaction with oxygen. Both metals and non-metals, how they are reacting with oxygen. So, write down today's heading in materials chapter, that is a reaction with oxygen. Okay, reaction with oxygen. Yes. Do you know any idea whether all metals are reacting with oxygen? What about the non-metals, whether it is reacting with oxygen? Yes. See, one simple example I will show you, students. Here, have you seen this iron? See, if iron nail or any iron material, if it is knife, anything, see, if you are going to expose to that world, to the atmosphere, after some time we can see something depositing on the surface of that metal. See, this is called as rusting of iron. What is it? Rusting. See, rusting of iron. What happens here? Rusting means there is a deposition of, see, rust we can see. Actually, this is a chemical reaction takes place in iron. When iron is reacting with oxygen, we can see this rusting. To avoid this one, what we are doing? For our window rods, we are painting. First we are giving some coating, zinc coating we are saying. Upon that we are painting that one to avoid the rusting. So rusting is a chemical reaction takes place in iron in the presence of oxygen. To avoid this one, what we have to do? We have to paint the iron materials. Okay? Yes. Now rusting of iron. Now tell me students, can you predict what is the chemical reactions in this? What is the chemical reactions when the rusting is takes place? Can you predict the chemical reaction, what it is going to happen? Yes, I will write here. Do you know the symbol of iron? That is Fe. Fe is going to react with what? Oxygen. It is reacting with oxygen. If it is in atmosphere, we can see the moisture, humidity and all. So in the presence of water, it is giving some other compound, that is a rusted iron we are getting. Okay, the formula of that one is FeOH. Okay, if you are going to balance this one, can you balance? Just to try to balance these chemical equations. This is an activity or as homework to you. Okay. Yes. Can you give any other examples? Same as that, any other metals can it give oxidation, or else when it reacts with oxygen, what happens? Sometimes if you have any silver ring, or else if you have any silver anklets, we can see something tanned, color is going to tan. Okay, something black color we can see depositing on that. That is also that is silver is going to react with oxygen. What about the gold? Whether gold is reacting soon with oxygen? No. So otherwise, if gold is reacting with oxygen, it is going to rust or else tan, means very difficult to use. No. So we are not that is not going to. It is very soon it is not going to react with oxygen, but the iron is very fastly, very quickly it is going to react. So if you are going to keep iron nails or anything, it is openly if you are keeping, that is exposed to air, means surely it will give rust, or else it is the color will change. Okay. Yes. Next we will do an activity and we will see whether these rusting of iron, or else what we have got here, this is called as oxides of iron. Okay, we will see whether these oxides of metals are acidic or else basic. Okay, we will try whether these oxides of metals, now it is iron oxide, whether it is acidic or basic. To know this idea, we have to do a small activity. We will do a small activity. See here, the same thing. What about the rust deposit on this? We have to remove that one. So already I have removed that one, and I have tried to dissolve with water. Okay, I have taken a big glass. This is a test tube. In test tube I am taking water and I am adding the rust. Okay, already I prepared this one. Now I am going to stir this one by using glass rod. Can you see now? Carefully you have to observe, student. Yeah, whether you can see what is any changes? Here it is not going to dissolve. See, it is not going to dissolve. See, it is not going to. Instead of this, if you are going to try to dissolve any sugar or salt, means very quick, very easily it can dissolve, but it is not going to dissolve. Now, I am going to test this solution with litmus paper. Do you know litmus paper? Have you seen litmus paper? See, these are the two litmus paper. We have two colors here, blue litmus and red litmus. By seeing the color, we are naming these two litmus. This is blue color, so we are saying this is blue litmus. This is red color, so we are saying it is a red litmus. Come to know? Now we'll check that solution is acidic or else basic. Okay, I am going to take two different litmus papers here. So we'll try first in red litmus. See here, red litmus I have. I am going to dip this litmus. Look at student here, what happened to the litmus paper? Whether it changed its color? Yes, it changed its color. See here, it was red litmus paper. Now it turned which color? Blue color. What you have got here? I will write and keep here. Blue litmus paper turn into, red litmus paper turn into blue. See here, I will write red litmus turn into blue. Okay. We'll check in one more litmus I have here, that is blue litmus. I will check in this. See what happens. Blue litmus remains blue only. Now what you got here? Blue litmus remains blue only. Two observations we got. Now we have to tell or else confirm whether it is acidic or basic. Now we have to give the inference. What you are saying? Do you know any idea of litmus paper? Whenever the blue litmus paper turns to blue or else red litmus paper is giving blue litmus or turns blue means what it indicates? Yes, that is basic. It is basic. So here oxides of this metal is basic. Now what happened? Just remember student, red litmus turns to blue means that is basic in nature. So here we come to know that oxides of iron is basic. Yes, by doing one activity we got this answer. So we'll try one more activity to confirm this one, whether all the metallic oxides are acidic or basic. One examples we got. To confirm this one, I am going to do one more example, one more experiment. Okay? Do you know magnesium ribbon? Yes, in our lower class we used this one. In our 7th standard used. See, this is a magnesium ribbon. Yes, to understand this one, all the metallic oxides are acidic or basic. To confirm that one, to get more ideas, we are going to do one more activity. That is, we are going to take a magnesium ribbon and we are going to burn this one. Okay, and after burning, we are going to collect the ash of that. And next, we are going to dissolve that ash into small quantity of water, and once again we are going to test the litmus test. Okay, we'll start. Observe carefully what it is going to happen. See, this is a magnesium ribbon. Can you see the colors? See here the burning, how nicely it is going to burn. Yes, so I am not wasting this ash, I am going to collect this ash. Okay. See, completed. Yes, the reaction is completed. So I am going to collect the, which one? I am going to collect this. This is the ash. Okay. Next I will add small quantity of water to this one. Small quantity of water I added. Just I will dissolve. I try to dissolve how much I can, that much. It is not dissolving completely, but it is somehow I am making the solution over here. Okay. Yes. Next it is ready. It is ready. Next we will check what it is doing. So you have to take this, whether it is acidic or basic, what it is going to happen. See here, I am going to yes. Can you see the color change here? What happened? Yes, what happened to this? Here? Yeah, red litmus paper turns blue. What is observation? red litmus turns blue. What happens? Same thing here, red turns blue, correct. Next, one more litmus I have, that is blue litmus. I will check in this. What happens to this? What happened? No any changes. So blue remains blue, red turns blue. Okay. Now what happened? What we got here? Both the red is turns to blue, upon that blue remains blue. So it indicates it is basic in nature. So we come to know that two metallic oxides we tried, both also basic in nature. To confirm one more I have, see here, this is a sodium hydroxide. Okay. To confirm this, I will check in this red litmus here. What happens to that? Turns blue here. See, blue litmus I have. We'll check in this. What happened? No change. So 3 experiments we have done. We come to know that here the conclusion is, or else the inference is, red turns blue, blue remains blue. That is basic. So we come to know that by doing this experiment, metallic oxides are basic in nature. What is the conclusion we got from here? All the metallic oxides are basics. Okay. Metallic oxides are basic in nature. Okay. We come to know that metallic oxides are basic in nature. This is all about the metallic oxides. Okay. Next we will see what happens in non-metals, whether it is reacting with oxygen or not, and what is the result we are getting. Okay. Before that, whether we have in our body any metals are present in our body. Yes, we know that number of metals are there. Upon that, one main metal, that is iron. Iron is present in our body, that is in red blood cell, that is in hemoglobin, that is a hormones present in our body. In that there is a iron as a metal we have in our hemoglobin. Upon that, plants also having some metals. Mainly the magnesium is present in plant body, found in plant body, but it is not in, it is in the Mg form, that is not as it is in the magnesium form, that is present as a Mg2+, that is called as ionic. Okay. Ions of magnesium present in plant body, that is extra information what I have given to you. Yes, next we will see the same experiment or the same reaction with non-metals. Here we come to know that reaction with oxygen, that is in metal we are getting the basic oxides. Next we will see what happens in non-metals. Next we will see what happens to the non-metals when it reacts with oxygen. Okay, to get the what idea of this one, we are going to do an activity. Okay, actually we are going to take here sulfur. Okay, have you seen sulfur? See sulfur, this is a sulfur. See sulfur here, colors, just check the color. Next we are going to take one jar here. Okay, that is to collect the fumes of this one. Okay, one watch glass to close this one. Upon that, main thing here, this is a deflagrating spoon here. See, this is a deflagrating spoon. Deflagrating spoon it is. Okay, how it is? See here the shape. Here one more, see here hook is there to show. Okay, if you don't have this one, we can use if any bottle, lid of the bottle, and we can tie it into any iron what wires or anything. Okay, like that we can prepare it. Okay, implemented what apparatus it is. So this is already we have. So we are going to take sulfur in this. Okay, sulfur in this. I am going to show these to fire now. We'll see what will happen. Okay, closely you have to observe, carefully you have to observe. See here, we can see here it is burning. So to get more, see It is burning. Now it is start to burning. See, we can see the fumes here. To get that fumes, see, just I will do like this. So you can see now here. See, now it is getting the fumes. Okay. Now I am going to collect this smoke. The smoke I am going to collect. You can see now the color changed now. See here, smoke. If I am going to open, it is fumes are going out. See, this is the fumes of which one? Sulfur. Now sulfur is reacted with oxygen. When we are going to burn that one, it is going to react with oxygen. Now what happened? Sulfur is turned into sulfur dioxide. Okay. Now sulfur dioxide fumes are present in this jar. Okay. Yes. Now I am going to collect this. I am going to collect this one. See here. Now it is filled with sulfur gas. Okay. Sulfur dioxide gas. Now I will add small quantity of water to this one. Small quantity of water to this one, and I will mix that sulfur dioxide, sulfur oxide and water. See here, I just mix it as much as possible, that much it is going to mix here. Okay. After mixing, now we have to check whether it is that solution is acidic or basic. Now what happens here? Can you write the chemical equation? What happens here? Yeah. Okay, after this experiment we will write the chemical equation. Now we have to try whether it is acidic or basic. So what we have to do, see, while I am opening, the rest, the dissolved sulfur dioxide remains over here. Upon that, what is left over, it is going out. See, try to go out very fast. See, maximum I will mix. Yes, next we will check in the both litmus. See here, I have taken first blue litmus. Blue litmus it is. What happens to the blue litmus now? What happens to it? Blue litmus? Blue litmus turns red. Can you see here? Blue litmus turns red. I will check same thing in the red litmus. What happened? No changes. It remains same. Blue litmus turns red. Now both red. What happened? Blue litmus turns red. Upon that, red litmus remains red. So what happened now? Blue turns red. Red remains red. What it indicates? When it is ulta of this one, red turns to blue, we come to know that is basic. Now what it should be? Acidic in nature. Acidic in nature. In nature. So come to know that here the oxides of non-metals are acidic in nature. Oxides of metals are basic in nature. If you are going to confirm this one, you can try it in if you can try it in any acid like H2SO4 or anything. If you are going to try, you can get the same results. Okay, you can confirm. So I am not going to do one more experiment. So one experiment we have done, we come to know that what metallic, non-metallic oxides are acidic in nature. Can you write the chemical equation? Yes, what happened? First, what we have done? Sulfur. I will write here sulfur we mixed with, that is we burned sulfur, so we got sulfur dioxide. Okay, I am not going to balance here. Next, what we have done? We are mixed with water, dissolved with water, so we got acid. Okay, that acid, look at the chemical formula, H2SO3. Okay, that is sulfurous acid. If it is H2SO4 means we are calling it as a sulfuric acid, but one O is missing over here, so we are calling it as a sulfurous acid. Come to know now. Now what is the conclusion over here? Yes, here we come to know that all the non-metallic oxides are acidic in nature. Okay, so we come to know by doing an activity. Next, one more small activity I will give you, student. Make 2 columns. In that you have to write name of the base, any base what you have no. Okay, first I will do one small tabular column here. Okay, you have to complete that one. See, small tabular column, name of the base. Okay, any name bases you can write, any base. What are the different bases we know? Sodium hydroxide, potassium hydroxide, many we know. Anything you can write, calcium hydroxide, barium hydroxide, lithium hydroxide, anything you can write, and you have to find which metal is present over here. Okay, in sodium hydroxide, which metal? Sodium. Potassium hydroxide? Potassium. Like this you have to find out, write down the more and more examples and find out the metal present in that. Same as that, one more activity, name of acids here. Instead of this base you have to write here acid. One more activity it is, second one, here metals, not non-metals here. Okay, non-metals, in case of base we can see the metals, in case of acids we can see non-metals. We come to know here, see here we come to know that this is the acid. In acid we can see non-metals. Okay, okay. Any examples can you give? Yes, example for acid, any examples? This is for base I have given, base I have given. So same thing you have to write down for which one? Acid, anything. HCl acid. 2 columns you have to do. Don't do like this what I have done here. Okay, so 2 columns you have to do, and HCl, HNO3, H2SO4. So H2SO4. Which is a non-metal present here? Sulfur. Whether hydrogen is a metal or non-metal? Hydrogen is a non-metal. Okay, hydrogen is also a non-metal. The position in the periodic table is along with the metal, but it is not. They have some reasons for that one. You are going to study that is in your higher classes. Okay, this is all about today's class. So we come to know that in today's class we come to know that the metals reacting with oxygen, what happens to the metal when it reacts with oxygen, and what happens for the non-metals when it reacts with oxygen. Only that concept today we have completed. Okay, write down today's questions. Okay, write the balanced chemical equations of magnesium react with oxygen, and you have to write the product. Okay, when the magnesium react with oxygen, what happens? Upon that, ion react with oxygen, that is a rusting of ion. Okay, one more question. Sulfur dioxide react with oxygen. So three chemical equation you have to write. Okay, thank you students.